Alright, this section is titled Limits, section 2.4. This is the beginning of our study of calculus. The word limit tells you that you're reaching some sort of point where you can't go any further. So to understand this, we're going to start off with a function, f of x. Let's suppose f of x is equal to x squared minus 4 divided by x minus 2. Now, as you may recall, there's a domain issue here. X cannot be equal to 2. But the question here is, we know that x can't be 2, but what happens to f of x as x gets very close to 2? So that's the question we want to answer. So let's pick a number that's close to 2 from the left side of 2. So if here's 2 on the number line, there's 0, 1, 2, and 3. We're trying to get close to 2 from the left hand side. So let's make a table of values. Close to 2 from the left side of 2, 1.9 seems like a good candidate. And then we're going to figure out what y is, by plugging in 1.9. Now we can do it the roundabout way. 1.9 squared minus 4 divided by 1.9 minus 2, in which case you'll need parentheses. You'd have 1.9 squared minus 4 divided by 1.9 minus 2, and you get 3.9. So I put that in here. You want to get a little bit closer to 2. 1.99 would be fine, and you could either go and just go second enter and use the insert button above delete and add another 9. So this does shorten the step somewhat, and you get 3.99. But after a while, if you want to try getting closer and closer and closer, you don't want to keep repeating these steps. There's got to be a faster way. So on your calculator, if you go to y equals, let me clear all these, type in the function, and you need parentheses because of the order of operations, x squared minus 4 in parentheses divided by x minus 2 in parentheses. Now above the window there's a table set. What you want to do is change the independent variable into ask mode. Independent is your x. This dependent stays as auto. These two do not matter. Okay. Once you have it set up, go to table. And I seem to have some numbers there already, so if I push the delete button, I can get rid of them. So I'm ready to now build a table where I'm going to ask it to tell me what y is if x is 1.9, 1.99, and so on. And it quickly produces the y values, and that does save a lot of time. So, but be careful, if you go too far, the calculator runs out of space here and it'll round it up for you. So if I go one more 9 here, it'll write 2 here, which we know x can't be 2 because you can't divide by 0. But if you push the arrow and go over it, if you read down the bottom, you'll see that it's actually 1.99999. It just doesn't have enough space. And this isn't really 4, rather it's 3.99999. Okay, so I'm going to write those numbers here. Basically, we sense a pattern. If I have 1.9999, I have the y value to be this. So in conclusion, as you get closer and closer to 2, as x gets closer to 2, y gets closer to 4. 3.999 gets pretty close to 4. What happens if you approach 2 from the other direction? Let's build a different table. X, y. Let's go to 2 from the right side. So you have 2.1, you can get even closer, 2.01, 2.001, you get the idea. You can go to the table. Now you can either push delete, go over the x, or you can just type over it, over the 1.9. So I'm just going to do that, 2.001, etc. Okay. So you notice that the y values start at 4.1, 4.01, 4.001, 4.0001. Again, as x gets close to 2, y gets close to 4. So if this happens, that as you approach x from both directions, if the y value approaches the same number, we say that the function f of x has a limit, a limiting value of 4. Okay, so the limiting value of f of x as x approaches 2 is 4. The notation for this is we say limit, and beneath the LIM we put x with an arrow as x approaches 2 of f of x equals 4. Notice that there is no equals here. This is all together. The limit of all this is one piece, and the equals is here, equals 4. So in general, what we say is that if, this is a general definition, we say that the limit as x approaches some number a of a function f of x is L if f of x gets close to, it doesn't have to take on the value, it's close to L, as close to L as we please, by taking x sufficiently close to a. So we made it close to a, sufficiently close to that number 1.999 is approaching 2, sufficiently close to but not equal to a. Okay, so that's the basic idea of a limit. We're going to do the worksheet now, and we'll build upon this concept, and I'll explain more things as we go on. Alright, so you can go ahead and print the worksheet that's posted alongside this video. This is the first worksheet. So this has the definition of a limit. F has a limit L as x approaches a, and is written using this notation if the value of f of x, which is y, can be made as close to the number L as we please, by taking x close to a. So for the first question, we need to complete the table and then use the result to estimate the limit. We'll use our calculator to graph the function to confirm our result. So the way this is set up is we're looking at the limit as x approaches -4, and this is going to be a function f of x. So we'll go to y equals, clear out the old graph, parentheses for this, x squared minus 16 divided by parentheses x plus 4. We'll go to the table, delete all the other values, start from here, -4.1, -4.01, -4.001. So I'm going to write those numbers down. -8.1, getting closer to -8 it appears, but it needs to do that from the other direction also. So we'll start from afar and get closer and closer. We're trying to get close to -4. That's a -4 there. Okay, so -3.9, it's -7.9, and I bet the next one is -7.99, and it is. And this should be -7.999. You can double check that. Yep. So by looking at this, we're approaching -4 from the left side and the right side, and the y value is approaching -8. So you say the limit value L is -8. So that answers this question. Sketch the graph you obtained from your calculator. So push the graph button. You may have to adjust your window, but it looks like a line. Now it isn't really a line. There's a little secret to it. When x is -4, there's an issue. If you push trace and type in -4, you won't get a y value. It's undefined there. But what happens is, if you go to like -3.999, it's taking me down there. So the line is kind of like this, but over there should actually be a hole. The calculator is not capable of doing the hole, so we'll add the hole there. Okay, so there you go. That's the graph. Going back to the notes I had earlier, we could have looked into this equation here and checked the graph as well, but something here might have told you that the top factors, the top x squared minus 4 factors as x plus 2 times x minus 2 divided by x minus 2, and these cancel, giving you x plus 2. So this is y equals x plus 2, which is a line. Okay, there's a y-intercept, slope is 1. But because x can't be 2, we have to do a hole right there. When x is 2, this would have been 4, and there's a hole right there. Okay, so that's what was happening there. You get closer and closer to 4, okay, but not actually be equal to 4. Back to the worksheet. We have a few graphs given to us, and the goal is to answer some limit questions. We need to find the limit as x goes to 2 of the function, and f of x is represented here. So x-axis, x going to 2 from the left, 2 from the right, and you can see the y value gets closer and closer to 8. So essentially the answer, you would say the limit of f of x as x approaches 2 equals 8. And that's your answer. Pretty simple, and the graph is given. Next question, when x approaches 1, go to x-axis, approaching 1. Even though at 1 the dot is here, the function is defined here, we don't care about that value. We want to see what the limiting value is, what y value gets close to. As x approaches 1 from the left, we're getting close over there, 1 from the right, getting close to that point, and that point is 3. So limit as x goes to 1 of f of x equals 3. It is that y value. Alright, a couple more. Evaluate limit as x goes to 0 of the function. So the key is that as you approach 0 on the x-axis, from the left side, you're down here on the graph. So this is the left limit. The left limit is -1, this y value. When you approach 0 from the right, the graph is up here. The right limit equals 1. Now if the two limits are not equal, the left and the right, they're not equal, then we say that the limit of f of x as x goes to 0 does not exist. We do have an abbreviation for this in math. We go DNE, and you can actually type this in WebAssign if a limit does not exist. Okay, so what we've learned is that for the limit to exist, the left and the right y values need to be the same. Going back to the first page, that happened here. Left and the right, it was both approaching 8. Left and the right values were approaching 3. But here we did not. Okay. The last question here, you're approaching 0 from the left and the right side. So what happens to the y value is that it gets pretty large. This graph isn't really showing clearly, but if you were to make the window larger, your y value is shooting off to positive infinity. So the limit as x goes to 0 of g of x, whether you go from the left side or the right side, it's going off to infinity. Now infinity is not a real number. So we either say it's infinity or we say it does not exist. Now on WebAssign, infinity does show up as on the left side on the math palette, or you can just type in the word infinity. WebAssign is smart, it'll accept it, or DNE will work just as well. We'll finish off this part of the homework. There's another part of the section we'll do in the next video, but we'll finish off with this theorem, which gives you properties of limits. This theorem might look pretty scary, but it's actually just common sense. What it's saying is, if you have the limit of a function to be equal to a number L, and a limit of a different function as x approaches a to be m, then you can do a bunch of algebra with it. For example, if f of x is raised to r, then that limit will be raised to r. If you multiply a constant c to the function, it's the same as c times that limit. If you add these two limits, you can add the two answers, L plus m. The limit of f minus g is L minus m. We'll be using these properties and we won't even think about it. It'll be that easy. Okay, if you multiply the two functions, essentially you multiply the two limits. If you divide the two functions and do the limit, you just divide the limits, except this condition, m can't be 0. Why? Because you can't have 0 in the bottom. So let's put this to work. For this first one, we know that the limit of a function, we don't know what the function is, but it's 2. And the limit of another function, g of x, is -3. We're going to use the properties from here to evaluate this limit. So if you have f minus g, basically it's this limit 2 minus that limit, 2 minus negative 3, well, that's just 5. Now here we're using the scalar multiple property. If you have c multiplied, so you have 3 multiplied, well, just multiply it to the limit of f of x, which is 2, minus 4 is a constant, multiplied with the limit of g of x, well, that's negative 3. So it's 6 plus 12, 18. And that's pretty much it. So we'll pause here, then try the homework, and we'll start off with one more set of examples and little video for the second half of section 2.4.